Welcome back, everybody. This is our second class in JEE mains previous year questions for chapter moving charges and magnetism. We have made one video in this chapter before this video, and that video is available on our YouTube channels in a playlist section dedicated for JEE mains previous years. We have also started similar series for NEET previous years, so you can go to our channel's playlist section and can also find those videos. And if you find these videos useful, helpful, then do press the like button, share them as much as possible, and subscribe to our channel. Also, if you would like to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Even a small amount will be highly appreciated. So with this, let's start today's video. And in the previous one, we completed, I think, first 7-8 numericals. Yes, this was the last numerical which we covered, and now let's move to the next one. So question number 9. Let me adjust pen thickness. So a proton, an electron, and a helium nucleus have the same energy. They have circular orbits in a plane due to magnetic field perpendicular to the plane. Their radiuses are rp, re, rh, rhe. Be the respective radii. So we have to compare ratio of their radii, and we know that formula for radius in magnetic field R is equal to mv by qp. So now it is mentioned that they have same energy. So we know that relation between this mv term is momentum term. So relation between momentum and energy is twice mass times kinetic energy. And here energy is same for everybody. So kinetic energy is same. So let's put this formula here. So it will be 2m root ke divided by q by b. So now kinetic energy is same for everybody, and I think field is also same. Yes, magnetic field will also be same. So we can say if we are going to compare, then radius is proportional to under root of m divided by charge. So we have to take care or take into consideration mass and charge for all of these three, and then we will be able to compare their radiuses. Now let's move. So let first compare for the proton and electron. So we can write that radius for proton is proportional to mass of proton by charge of proton, and here radius of electron is proportional to mass of electron by charge of electron. And here we are only taking we can say magnitude of charge, not the positive negative sign. We are only taking magnitude of the charge. So let's divide both of these. So radius of proton by radius of electron will be under root mass of proton by mass of electron, and as both of them have same charges, proton's charge is positive 1 and electron's charge is negative 1 in terms of charge of electron. So the charge will get cancelled out. And as we know, we also know that mass of proton is greater than, very greater than, as compared to mass of electron. So this term will be greater than 1, or under root will be again greater than 1. So we can say that Rp by Re is greater than 1, or in short, radius of proton is greater than radius of electron. And if we see, where here we have two options only in which radius of proton is greater than radius of electron, electron. So we have only option B and C here available. Now going to, let's compare for proton and helium particle or helium nucleus. So helium nucleus is actually alpha particle, and it has a mass 4 times of mass of proton, and it has charge, we can say Q of alpha is twice the charge of proton, or we can say 2q. So for alpha particle, radius will be proportional to 4m, assuming mass of proton is m, 4m divided by 2q, it is proportional to, and for proton it is proportional to root m by q. Now let's divide both of these, and we will get r alpha by r proton is equal to root 4m divided by root m, and we will have here 2q, and here we will have q. So q get cancelled, root 4 is equal to 2, so get cancelled, root m and root m get cancelled, so it comes out to be 1. So radius of alpha and we can say proton will be equal. So we have an option here. In option B, radius of proton is greater than radius of electron, and radius of proton is equal to radius of alpha particle or helium nucleus. Moving to the next one. A proton and alpha particle with their masses are in ratio 1:4 and charges 1:2 are accelerated from the rest through a potential difference. So in the previous question, energy was same. In this question, potential is same. There is a slight difference in both of them, that if we have potential, then energy is given by QV. In previous question, energy was same. In this question, potential is same. Energy can be different. In previous one, energy was same, potential can be different. Here, potential is same, energy can be different. Are accelerated from rest through a potential difference V if the uniform magnetic field is set up perpendicular to their velocity ratio of their radii. So now their kinetic energy, we can say half mv square, it is the energy acquired by either proton or alpha particle, will be equal to charge times potential. So let me write it here small v, so that we able to get an idea of difference between velocity and potential. So half mv square is equal to q times v, and from this velocity is equal to root 2 q v, where v is capital V is potential divided by mass. And now radius, we can put this value in the formula for radius. Radius is mv, this v is small v, velocity, into qb. So r comes out to be m by qb under root times 2q capital V, where V is potential, into m, and we can further solve it. So it will become 1 by b stay outside, and we will have root 2 m v, m go inside the under root will become m square divided by m, we will have, and q while going inside the square it will become q square, and q by q square will be q. So here we will have q. Now out of all these terms, magnetic field is same for everybody, 2 is constant, and potential is same as mentioned. So we can write it like this, that twice of potential divided by magnetic field into under root of mass by charge. So these terms are constant as they are same for both proton and alpha particle, and these two terms, mass and charge, will be variable. So we can say radius is proportional to mass by charge. So now radius of proton will be proportional to, suppose mass of proton is m and its charge is q, and radius of alpha particle will be proportional to its mass, that is 4 times the mass. So 4m divided by its charge is double, so 2q. So now let's divide them. So we got a power cut, so our previous slide was gone, but we got up to here that radius was proportional to mass by charge. So now let's write this formula for both proton and alpha particle. So for proton we will have, assuming its mass is m and charge is q, and for alpha particle we will have its mass 4m, 4 times the mass of proton, and its charge is twice the charge of proton. So we have to find out ratio of proton by alpha particle. So radius of proton by radius of alpha particle will be root m divided by root q, root 4m divided by root 2q. So here root m get cancelled, root q get cancelled, and we are left with root 2 by root 4, and it will be root 2 by 2 and 1 by root 2. Option A will be the right answer. Let's move to next one. So in an experiment, electrons are accelerated from rest by applying a 500 volt potential. Calculate the radius of the path in if a magnetic field of 100 millitesla is applied, charge and mass are given. So we have to find out, we can say radius, and radius is given by mv by qp. We know the mass, we have the charge, we have the magnetic field, we have to find out velocity, and velocity can be found out as it is the particle are accelerated through potential of 500 volt. So kinetic energy half mv square is equal to q times the potential, that is v, that's capital V for the potential. And using these values, value of velocity comes out to be 2qv by m under root, putting these values here. So we will have m qp 2qv by m. Now it will be 1 by v outside as it is, and here we will have 2m times velocity potential divided by charge. So our magnetic field is 100 millitesla, or 100 into 10 raised to power minus 3 times 2 into mass, that is 9.1 10 raised to power minus 31, times potential, that is 500, divided by charge, that is 1.6 10 raised to power minus 19. So 500 into 2 will be 1000, and that power will be adjusted here. So it will be basically 1 by 10 raised to power minus 1, 100 into 10 raised to power minus 3, into 2 into 91 by 16, adjusting their decimals. Oh, so remove the 2. 500 into 2, 500 into 2 is 1000, and 1000 is adjusted here with 3 powers, and we will be left with 10 raised to power minus 28. So 10 raised to power minus 28, and this 19 will go up with positive sign, plus 19. So here we will have 10 raised to power minus 9. So it will be minus 1, 1991 by 16 into 10 raised to power minus 9's root is 10 raised to power minus 3. So we can solve it further. It will be 10 into 10 raised to power minus 2, 91 by 16. Now let's see which of the option fits perfectly. Oh, we made a silly mistake here, and sorry for that mistake. and that mistake was that here we had 10 raised to power minus 9, and we cannot directly take under root of power because 9 by 2 is not 3. So we made a mistake here. So let me correct that. It is minus 9. What we will do? We either make it 10 or we either make it 8. Only then it will be divisible by 2. So we make it 10. So it will be 10 raised to power minus 1, 90, 910 by 16 into 10 raised to power minus 10. Now we can take it out of under root. And now it will be 10 raised to power minus 5. So 910 by 16 into 10 raised to power, we can say, minus 5. Now I'm going to approximate it. As we know that root of 900 is 30. So I'm going to take it 30. And root of 16 is 4 into 10 raised to power minus 5. And this will be 7.2, I think, 7.5 or something, into 10 raised to power minus 5. And we have a yes, we have a 10 raised to power minus 1 with us here. So 10 raised to power minus 1, and we have a 10 raised to power minus 1 with us. So it will become something like 7.5 into 10 raised to power minus 4. And now comparing with the options, here it is, option D will be the right answer. Moving to the next one. The region between y is equal to 0 and y is equal to D contains a magnetic field B is equal to Z. So let's draw the diagram first. Particle enters with field velocity in x direction. So here is the coordinate system. So suppose this is x direction, this is y, and y0 to yd contains a magnetic field B is equal to Bz. So y is equal to 0 is the x-axis, and y is equal to D will be this one, this line suppose. And here we have magnetic field going in the z direction. So magnetic field here is something like this. Here we have magnetic field in the z direction. B value is P. Now particle with mass and charge Q enters in the region with velocity. So suppose there is a particle which enters here with velocity V is equal to Vi. Now, so our field is in K direction, magnetic field is in K direction, velocity is in I direction. So we can say force is equal to Q V cross B. So we are just only checking here direction. So it will be Q times V is in X direction and magnetic field is in K direction or Z direction. So I cross K will be minus J. So force will be in negative of J direction. So force will be downward here. So force will be down. The acceleration of the charged particle at a point of its emergence at the other side is. So we have to find out acceleration. Now first let's draw the path of the particle, and D, value of D, that thickness, this D is also given, that D is equal to mv by 2qp. So here it is not mentioned that from which point the particle enters, it can either enter at y is equal to d or somewhere in the middle. So no problem, we just assume the simpler one. So as we know that charge force will be acting downward on the particle. So suppose particle enters here, so particle will move like something like this in the circular orbit. And what we have to do here, we have to find out this angle of emergence, and that we can create a horizontal line here. So what we have to find out, if we are able to find out this angle theta, then we will be able to find out the acceleration, because we know that force on a charged particle is given by q v b sine theta, and here angle between velocity and magnetic field is 90, so force will be q v b, and from this acceleration will be q v b by m. So we have the we can say magnitude of the acceleration. We just have to find out its vectors, and for to resolve this acceleration in vectors, we have to find out this angle theta. And how we can find this angle theta? That can be easily done with the help of some mathematics. So for that, first we have to find out that what will be the radius of the particle. So radius of the particle is given by mv by qb. That's by default formula for the radius. And if we compare it by d, we know that d is equal to mv by half of qb. So here d is half of the radius, means even if the particle enters at somewhere point midway between this region, it will cross it perfectly. And as radius is greater than this thickness, so particle will not be able to complete any complete circle inside this thickness. So let me draw that as our radius is greater than this slab thickness, so even if particle enter at this point, it will not be able to complete a full circle here, because thickness of the magnetic field region is less as compared to the radius. Now, as I already mentioned, that it is not mentioned in the question that at which point we are entering. So we are taking what we do, we assume that we are entering at one corner, and then we will be able to take the maximum effect of the magnetic field or maximum possible rotation. So let's assume that we are entering at this point. So if we are entering at this point, our charge will rotate something like this, and at this point it will go normally or straightforward, because after this point, suppose this is point A and this is point B, after point there is no magnetic field. Sorry, not B, C we have to use, because B is already used. After point C there is no magnetic field, no force will be acting, so charge will move in the straight line, and we have to find out this angle. And assuming that the origin is our point of rotation, now what will happen? Now let's find out the center of rotation. Normally it is always assumed that center of rotation is at the center of the coordinate axis, but we already know that radius is greater than the thickness of the slab, and thickness of the slab is r by 2. So this distance, we can say AO, this thickness, this distance AO is equal to r by 2. So we have to move further r by 2. So we have to further move r by 2 to this point, so that this distance A2, we can say F, so that distance AF becomes equal to radius of the rotation of this charge particle. So here AF will be the radius of rotation of this charge particle. Now if we join these 2 points like this, then Fc will also be equal to radius of the charged particle, because till point C particle is rotating in the circle. So distance Fa is equal to radius, and Fc is also equal to the radius of the particle. Now let's find out the other distances. So we know that Fc is equal to AF. In diagram they may not look equal, but AF is radius of this circle, and FC is also radius of this circular motion. So FC is equal to AF is equal to R, and FO, this FO distance, as we know that AO is equal to R by 2, so OF is also R by 2. OF is equal to R by 2, as AF is R and AO is R by 2, so OF will be R minus R by 2, so R by 2. Now let's consider we have an angle phi here. So for this triangle OCF, for triangle OCF, we know the value of base, we know the value of hypotenuse. So cos theta, that is cos phi, that is base by hypotenuse. Base is R by 2 and hypotenuse is R, so it will, cos phi will become half. Now let's find out relation between theta and phi. So if this is phi, this again will be phi, and we know from here theta plus phi will be 90, and if this is phi, this angle will again be phi. So we know the phi, we know magnitude of acceleration. Suppose if acceleration A is here, then its we can say x component will be, its x component will be A cos phi, and its y component will be in the negative y direction, will be minus A sin phi. Now if value of cos phi is half, means theta is, we can say 60 degree, and at 60 degrees sin phi will be root 3 by 2. So our acceleration vector will become A cos phi, that is half, minus A sin phi, that is root 3 by 2. Now taking A common, what we will have? We will have Q VB divided by M, and half I in x direction and root 3 by 2 in the y direction. So option A will match. So let me let us go through again the basics of this question. That it was given that we have a region of magnetic field extended up to some distance in y-axis. So we plotted that region, and value thickness of that region is given mv by 2 cubic. Now it was given that we have a charged particle entering in this region. Now in question it is not mentioned that at which point this charged particle is entering. It can enter anywhere between O and A, and depending upon the value where it enters, its acceleration component, components of acceleration will change. Magnitude will stay the same. That angle theta and phi will change depending upon the place where it is entering. So we consider that it is entering at one of its edge, and after entering there will be downward force acting on it, so it will move in a circular orbit. Now we calculated the value of radius. Radius comes out to be mv by qb, and here distance, the thickness of this region is mentioned as mv by 2 qb, means thickness is half of the radius. So means the center of rotation will be outside of this thickness. So we plotted this center of rotation as point F. So F into A, F to A is that equal to radius, and F to C, C is the point where this particle after rotation left this this region of magnetic field, so comes out of this region of magnetic field. So Fc again will be equal to radius. So we know here, we know the value of Fc. Value of OF can be found out easily, that as AF is equal to radius and OF is equal to radius minus value of AO. AO is equal to thickness and thickness is equal to R by 2. So now using OF and FC, we can find out sine and cosine components, and then we can resolve this acceleration into its corresponding components. So this will be the basics of this question. Now moving to the next one. An electron, proton and alpha particle having same kinetic energy. I think we solved this question, and it was, I think, question number 9. This was the question and we already solved it. So you can go, you can say rewind this video and find the answer, and its answer is that radius of proton is greater than radius of electron is equal to radius of helium particle in case of same energy, not in case of same potential. In case of same potential, we have to solve it separately. In case of same energy, these radiuses follows this relation. Let's move to next one. Okay, oh, that was question number 13. So it was option B. So a negative test charge is moving near a long straight wire carrying a current. The force acting on the test charge is parallel to the direction of the current. The motion of the charge is. So suppose we have a wire. This is our wire, and as we know, suppose there is a current, upward current in this wire. So direction of magnetic field will be something like that. According to right hand screw rule, magnetic field will be something like this, that it will be coming in front of screen and going from the bottom of the wire. It will be like that, that from the this say this is left side and this is right side, not right side. So from the left side it's coming towards you out of screen, and in the on the right side it's going into the screen, you can say below the wire. So force acting on a charged particle is parallel to the direction of current. Suppose we are taking charged particle on the left direction, because here it is not mentioned that particle is either on left or on right. And why it matters? It matters because on the left side magnetic field is out of the screen, and on the right side magnetic field is inside of the screen. So, assuming that, let's take a coordinate axis here. That suppose these are the coordinate axis. So this is x, this is y, and this is z. So here current is in y direction. Normally current does not have any direction, but because its direction is related to the motion of the electron, that's why we are taking direction, that upward direction or y direction. So in the left side magnetic field is in the positive z direction, and on the right side magnetic field is in the negative z direction. So we have to choose one side. So we are choosing that particle is moving in some random direction on the left side, and force acting on it is parallel to the charge, as per mention, parallel to the direction of the current. So force is in we can say z direction. Oh, sorry, y direction. So force is in positive j, field is in positive k. We have to find out the velocity or motion of the charge. So we know that force is equal to q times v cross p. Now we have a negative charge, so we will have negative here, and we are only discussing about direction. So force is in j with negative sign. Charge does not have any direction. Velocity we don't know, so take question mark here. cross product with K. So we have to put a value here. Of course, only I will come here. Only then this will have solution. So we have to find it will be either positive I or negative I. So I cross K, if we put I here, I cross K is negative of J, and negative negative becomes positive, so question mark will be I. Hence particle is moving in the positive x direction, means particle is moving something like this, and from this we can say particle is moving towards the wire. So this is for the we can say left side. Now let's suppose now for the right side. For the right side again, force is in J and magnetic field is now in minus K. So if magnetic field becomes in minus K, now we have to put here minus I, means for the right side charge will move like this. So in both of the cases charge is moving towards the wire, not away from the wire. So option B will be the right answer. Let's move to the next one. In certain regions, static electric and magnetic field exist. The magnetic field given by this value, if the test charge with velocity is given, experience no force in this region, then the electric field in this region in SI units is. So we have to find value of electric field, and we know that when charge particle experience no force, it means that electric and magnetic forces are balanced. So we can say QE is equal to Q V cross P. So Q get cancelled, or we can say value of electric field will be cross product of velocity and magnetic field. So we can take cross product. So it will be I J K. First comes the velocity, so V node is constant, it is outside of cross product. 3I minus J 2K. Again here B node is scalar, so again out of cross product, and it will be I 2J minus 4K. So taking cross product, and outside we have B node, V node, I times, sorry, oh, we have to take only magnitude here, not the vector form. So it will be 1, it will be minus 1, 3, minus 1, 2, 1, 2, minus 4. So I times 4 minus 4. So we are not going to have I component in the electric field, and there are two options related to that. Minus of J means it will be minus 12 minus 2 plus of K, and we will have 6 plus 1. So it will become B node, V node, 14J plus 7K, and from the available options, option C be the right answer. So with this we end this video here. Hopefully what we have covered here is helpful to you and understandable also. Again, if you have any doubts or suggestion, you can put them or leave them in the comment section. I will try to resolve them. And if you like this video, then do press the like button, share it as much as possible, and subscribe to our channel. Also, if you want to support us financially, you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any help, however small, will be highly appreciated. So with this, again, thanks for watching, and we will meet in next video.